Now this is something that you don't get to see every day. This is a ferroresonant voltage regulator. This is a voltage regulator that can regulate your mains voltage extremely accurately, may I add. Input 220 plus or minus 15%, which means the voltage can be like 180 to 260 volts, and the output will be 220 volts plus minus 1%, or 230 in this case. It's got two different taps. So what I've done here is I've hooked up two meters. We've got a Fluke 76 which is connected here to the output, and I've connected it to the 220 volt tap. And this meter is measuring the input voltage going into the plug here a bit dangerously. Perhaps not the best way of doing it, but no hands are gonna go near there. And then I've got it plugged into this variac. So we're gonna have a bit of a play around with this. I'm going to vary the input voltage and we'll see how accurate the output really is. I think you're going to be quite surprised. So when I plug this in, the variac will get power. So here we go, 3, 2, 1. Here we go, we got 235 in and we got 223 coming out right now. Let's see, can we get a better lighting situation here maybe? I realize the camera doesn't really want to do a good job because of my new lamp, it seems. But yeah, we got 235 going in right now, 222 coming out. Variac displays the same. I could use that meter, but I wanted something a bit more accurate. So when I tweak this knob, I can change the voltage up and down. Let's see what current we have. Apparent current 800 milliamps right now. It's gonna go up if we decrease it, and it's gonna go down if we increase it, if we increase the voltage or decrease the voltage. So let's see, 240 now, that's pretty hot. So let's put it at 230, which is nominal mains voltage, or at least it should be. Then we get 223 volts out, which is perfect regulation. Let's go down a bit. 220 in, 224 out. Very interesting. Okay, let's go up. Let's start by going to the high end of the scale. So let's go. There's 230. We get 223, 235, still 223, 240 volts. Now it went down a little bit. It's 222.6. which is extremely good. And remember, this is also unloaded, so the voltage is going to be a little bit high on the output. It's probably going to be a spot on 220 when it's loaded. Okay, 240. Let's crank it up even more. 245. And it's 221.8. The voltage is going down a bit on the output as it goes up, but that's normal behavior. Let's go up even more. 250 volts, 221. Let's go even higher. 253, that's the highest I can go on this variac. 220.9. So that is perfect. Let's bring that back down to a more acceptable voltage. Yeah, that's incredible. Incredible accuracy. Now let's go down. So 230, we already looked at 220. So let's go down. There we have 225, 223, 220. At 223, it's 1.1. It's 1 to 1. Okay. 220 volts. 215 volts. Still rock solid. In fact, the output voltage is probably going to start going higher now because of the way these work. But it's still not going to get that high. 210. I'm gonna look at the current here now. Yeah, we're at 2 amps, it's fine. And that current is a lot of capacitive current and inductive current, so it's not actual power. In fact, this thing is probably only dissipating a couple of watts right now into heat. But yeah, 210 volts, 225, absolutely perfect, 224.9 there. Let's go down a bit more. Here we have 200 volts, and we are still holding a rock solid 220 volts, which is exactly what we want. So let's keep on going down. Here we have 190 volts, 226.4. So yeah, the voltage on the output is starting to go up a little bit right now, because we're getting out of the range that this thing is meant to operate on. But this is still absolutely acceptable. This is very good, extremely good, I would say. Extremely good accuracy. Let's keep on going down. 180. We have 226.8. Yeah, this is incredible. And I tested this a bit off camera. I brought the voltage down quite a lot, and what I saw was actually unbelievable. Okay, I'm just gonna watch that current there, 3 amps. I've got a 4 amp fuse in the variac, so it might actually pop. We'll see though. If it pops, I'll put a bigger one in temporarily. Not the right thing to do, but 170 volts. We have 227 on the output. So yeah, it's going up a little bit right now, but the curve, the voltage curve on these, they tend to look a little bit like that when you run them on outside their range. 3.3 amps. Okay, let's keep on going. 160 volts, still rock solid 220. Alright, let's go even lower. 150 volts, 227, rock solid. The variac starts to buzz quite a bit when you start lowering the voltage. I think I might have to turn it off here and make sure it's not overheating on us. Let me see. Nah, there is no heat at all in that thing. These things are bloody impressive, these little variacs. They can handle a pretty crazy overload. Just plug it in. Okay, everything is good. So let's keep on going down. We're at 150, right? Okay, there we go. 150. It's drawing almost 4 amps right now. I gotta check what fuse size I've got in the variac real quick, because I've got a feeling a fuse is gonna pop. And, you know, the variac can handle a overload for a short period of time. So I'm thinking we might put in a bigger fuse just temporarily. I know that's not the right thing to do, but let's see what this is rated at. It is a 4 amp. It's a slow blow 4 amp fuse. I don't think I have replacements if I blow that. That's why I'm thinking about putting a bigger one in, even though that's a big no-no. You shouldn't do that. Do we have a good fuse maybe? This is an 8 amp fuse. Yeah, I may put that in, but that might be a bit extreme. This is another 4 amp. Okay, I've got spares. Let's run the proper fuse, and if it blows, it blows. Fuses are cheap, so yeah, let's run this fuse, and if it blows, well, then it blows. Okay, that should be good. Let's plug it back in. Okay, everything is good. So let's continue our experiment. 150. 227. It's rock solid. It doesn't move at all. Let's keep on going down. 140 volts. We're overloading the fuse now. 4.2 amps. Still 227. 130. 226.8. 120. 226. 110. 225. 100. 224. 90. 223. 80. 221. Almost 222. 70. 220. 60. 218. 50 volts. 214. 40. Oh, the variac is making bad sounds. 40 volts. 211. 30 volts. 207. 20. 200. 12 volts. 13 volts. 12 volts. 150. And we're turned off. The fuse didn't blow amazingly. That 4 amp fuse held on. It held on for dear life. Yeah, it's hot now. Variac is cold, but the fuse is hot. No wonder. That was impressive. That was seriously impressive. I was not expecting that. That is insane. Let's see. 4 volts and it's 40. Current is ridiculously high already. 5 volts, 50 volts on output. 6 volts, 60 volts. 7 volts, 70 volts. 8 volts, 80 volts. Let's see, 9 volts. Can we get 9 volts? It's kind of hard. The variac is coarse. 9 volts, 88 volts on output. 10 volts, 102. 11 volts, 113. 12 volts, 130. 13. 14 volts. Whoops. 14 volts. 13 and a half. We're up at 187. Let's see where we hit 14 volts. 190. 15 volts ish. 193. 16 amps. Or volts, sorry. 195 volts out. This is insane. 17 volts, 195. 18 volts, 197. 19 volts, 198. 20 volts, we're up at 200. I don't know what to say. This is incredible. The amount of accuracy this thing has it's insane. At 20 volts input, this thing can power things. Even at 12 volts input, this thing can power some things. That's insane. You could run extremely sensitive equipment on world's shittiest power supply with this. This is... I am I'm blown away. That's one thing for sure. I knew it was gonna be good, but I didn't expect it to be this bloody good. Holy shit. Yeah, this is impressive. And this thing works entirely using a set of inductors and resonance capacitors sitting here. There's 4 of them. There's 4 resonance capacitors in here. Yeah, this is incredible. This is crazy. This is outright insane. The accuracy of this thing is just, yeah, it's a whole different world. It's insane. But yeah, we didn't need any fuses. We didn't pop the fuse in my Variac. I was not expecting the fuse in my Variac to hold on. I am very impressed that it took double its rated current, because we did have like almost 7 amps at these really low voltages, because of the way these ferroresonant voltage regulators, how the way they work, they draw a lot of current at low voltage. Although there's no power loss, it's just capacitive and reactive power. It's not real power, but the current will still pop the fuse. So yeah, this is crazy. This is truly amazing. But yeah, I was going to put in a too big fuse into the Variac just temporarily while doing this test and monitoring the temperature of the Variac, but we didn't even need to do that. Yeah, I am impressed. I am extremely impressed. Yeah, this thing is able to regulate the voltage better than it advertises. Yeah, this is crazy. But yeah, the way these work is extremely complicated, and I don't think that I could explain it that well, even if I tried. So I'm gonna leave the explaining part of this, how these work, to a YouTube channel called Diode Gone Wild. They've made an absolutely amazing explanation on ferroresonant voltage regulators. And they are, yeah, these things are works of absolute art. Whoever figured this out, they really do deserve, yeah, I think they deserve a Nobel Prize, because this is, whoever figured this out, you knew what you were doing. But yeah, it's been a long time since I made a video. As you can see, my bench has gotten quite a bit of an upgrade. I've moved the current limiting bulbs. Oh my gosh, this chair. I've moved the current limiting bulbs down here now. I need to redo these labels, but whatever. And I've replaced my bench lighting with a proper light, so now I can actually see what I'm doing. And yeah, I moved these down so they're more accessible for changing bulbs and such. Maybe I put them a bit too far down though, but whatever. It's good to have them visible there. So now I no longer use these for bench lighting, which is good, because incandescent bulbs are impossible to find. In fact, I'm very lucky to have these 2 bulbs. I've also got 3 spare bulbs here. But that's it. I don't have any more incandescent bulbs, and you can't go and buy them anymore. They've been phased out long ago, and for pretty good reasons, to be honest. However, these have a purpose in every electronics shop. They are extremely good at providing current limiting when you're testing things that you don't trust. You connect these in series. That's what this outlet is here. This outlet is wired in series with these lights, and if you connect something to this and it's shorted or has a problem and draws too much power, the lights will just light up and limit the current. These are a must-have when you work on homemade circuits and stuff too. Especially like me who work on vacuum tube equipment a lot. These tell you so much. And if there's a problem, they'll light up instead of things smoking or burning up, which is very good. And the light option here on this switch, it just shorts this outlet basically. And if you press it, you can ensure that the bulbs are working. Before I used to use them as bench lighting, but they were not that great. Now I've got this thing, and this is insane. This is 10,400 lumens. It's a electronically ballasted fluorescent lamp. It's got two 58-watt tubes in it. It's pretty damn bright. It's extremely bright. They were selling these for a ridiculously low price because they're trying to get rid of fluorescent tube lighting right now. The EU has decided to stop all sales of fluorescent lighting in August, I think it is. So, stores are trying to get rid of their old stock. So yeah, this was an insanely good deal, and as you can see, it does an incredible job of lighting this bench up. It's amazing actually. The only thing I kind of wish was that it was located a bit further out, but it's a bit too long for that, unfortunately. But this is still absolutely incredible. I can actually see what I'm doing for once. These lights, they were pretty bright too, and then I had that thing hanging over there in the middle here. And it worked, but it was never bright enough. You had to really focus on what you were doing. It was just straining my eyes a lot unnecessarily. This is insanely bright instead. It's almost too bright, but I would rather have it that way. It's a cold white 4000 Kelvin as well, so it's pretty good. It's perfect for working, and it should last a really long time. I don't know what the lifespan rating is of those tubes, but I think they're rated for I don't know, 50, 60,000 hours, maybe something like that. And that is running them with electromagnetic ballast. I'm running them with solid state ballasts. Well, electronic ballasts is what I'm trying to say. So I wouldn't be surprised if these tubes last 100,000 hours or even more. And I think I'm gonna try and pick up some stock of those before it's too late though, because 58-watt fluoro tubes are certainly not the most common to find anymore. But yeah, these are very bright. I like it. It's a perfect color temperature for working on stuff. Normally I prefer warm white lighting, but this is excellent for actually doing in soldering and stuff, because warm white lighting is quite nice, but on an electronics bench like this, where you want a very neutral light so you can see better what you're doing, this is quite nice. Yeah, pretty pleased with it, to be honest. It's just mounted with some steel wire because it works, and I can't mount it flush to here because the support beams there, and there's nothing I can do about those. Those are absolutely 100% impossible to move. So yeah, what I could have done is I could have tried to get my hands on one of those lights out of a control cabinet, screw that up here, because I know 30-watt tubes for those exist, which aren't that long. One of those would probably fit perfectly here, and I could mount it right on the edge here, so it would light up a bit further out. But this is a pretty good solution too. But it would probably be better if the light was coming more from this angle here downwards, because as you can see on the video there, the multimeter displays were pretty difficult to read, and I realize now afterwards I should have done it sitting down and, you know, having the meters like this, maybe even turn the bench light off. That might have been even better solution. I don't know. The other lighting in this room is just this LED fixture and this LED fixture there, and there's no fill light here right above the desk, so that's a bit shitty. I've been thinking about putting up some sort of lamp here too, so I can get more even light. So this light plus that light would probably make things a bit nicer than it already is here. Yeah, I'm pretty happy with this though. This is pretty good, I have to say. But yeah, it is a little bit blinding because it shines light out here. I think one thing that could be kind of cool to do with this lamp is to take the cover off and spray paint this part of it that is facing against me. Spray paint that black so that the light doesn't blind me from the edge of it here, so it shines downwards and into the wall and reflects back instead. That might make it a bit nicer for my eyes, because when I sit here just looking at the sockets, for example, the light is a bit sharp in my eyes, and it would be nice to have, you know, that part of the covered up, so, you know, from here to here basically. And that would be pretty good. That may actually be a modification I'll do, just to kinda make it a bit nicer. But yeah, it is very bright though, I'll give it that. It's overkill, absolutely overkill. But yeah, this video just turned into a 30-minute video, and it was only meant to briefly show this thing in action. Temporarily wire it up and everything. I think I'm gonna install this in my room actually, because I've got a lot of antique radios and stuff which really doesn't like the hot mains voltage that we have here. It's closer to 240 volts, which is fine for everything modern, but older stuff tends to get a bit sappy about it. Transformers and stuff tend to run really hot, and those transformers are irreplaceable, so if they burn up, that's it. That's the end of the radio basically. So, well, not really. There are solutions to those problems, but you know, it's a lot of work for something that could have been avoided. But yeah, these things are awesome, and I think I'm gonna install this in my room. I'm very happy about this find. This came from a industrial PLC system, and it is absolutely awesome. It was a salvage, basically. This thing would have been thrown away if I didn't want it, because we were taking it down at work, and I've always wanted one of these, and when I saw this thing for the first time there, I was like, holy shit, there's a ferroresonant voltage regulator here. I gotta have to have that whenever we tear this down, and well, here I am. I've got it. I actually never thought I would lay my hands on one of these. Yet here I am. I have one. And it seems to be quite old too. If that's a date code, then it was made in 1989, week 26. It's a Fiskars CVT, constant variable transformer type 1 kVA, input 220 volts at 50 cycles, output 220 plus minus 1%, and plus minus 15 on the input. And as you can clearly see, this thing is able to regulate voltage much outside of its rated range. It's actually pretty damn impressive. Obviously, I don't have a load on it when testing this. If I had a socket with a plug on it, we could put it under load and run a loaded test. However, my poor Variac here is not going to like me doing that, I can almost assure you. But yeah, these are cool. These are really, really cool. The way these work is truly fascinating. And yeah, I don't have that much more to say. I want to find some wiring stuff so I can hook this thing up in my room now. I need this plug can stay, but I need to install it properly via the grommets. I should have done that right from the get-go, but I didn't. And then I need to get a wire going out. Yeah, I put these wire ferrules and everything now, because I'm allergic to bad connections now. So yeah, this wire can probably stay for the input. I just gotta redo it properly, because yeah, it's 1.0 square millimeter, and this thing, 1.0 square is gonna be fine for a 1 kilowatt, 1 kVA rated unit. The current will rise if the voltage drops very low, but if there's a heavy load on it at that moment, the 10 amp fuse is just gonna pop in the house. I think that's more than enough to protect this thing. It's so bloody big that I don't think there's gonna be a problem. It might not be too bad of an idea though to put like a 4 amp fuse or breaker in series with it on the output, just so that, you know, if you overload it like crazy, it's going to pop the breaker and you know, not sit there and just overheat. Although making something like this overheat, that's gonna require some effort, I can tell you that. But yeah, what a beautiful piece of art. Absolutely fascinating that it can work so well.